Okay. So the following reaction produces 0.022 grams of calcium carbonate. What mass of calcium chloride was used as the reactant? So we want to know how much is needed. So we're doing the opposite. So we can still do the same calculations, no matter if we are starting with the amount of reactants or starting with the amount that's produced, okay? We want to know how much was needed to start with in order to produce a certain amount of our product, in this case, calcium carbonate, okay? So we are producing 0.022 grams of calcium carbonate. So that sounds very small, but we're just going to go with the number right now. What mass of calcium chloride was needed to produce that amount of calcium carbonate? It then gives you already the molar mass of calcium carbonate and the molar mass of calcium chloride. Okay, so our first step, always, you must make sure you have a balanced equation. So looking at this equation here, I'm going to look at this and I'm going to say this does not look like a balanced equation. The main things that I'm recognizing as not balanced is the chlorine and the sodium on both sides. So that's the first thing that we're going to work on together, is to balance the chemical equation. Then it's asking you to identify your conversion factors that are needed using molar masses and mole ratios, and then set up your dimensional analysis. Okay, so I'm going to switch over and start getting this written out, starting with the chemical equation. Calcium chloride, we're going to say this was aqueous, I believe. So this is happening in solution, aqueous. When calcium chloride reacts with sodium carbonate in solution, what forms, I'm going to run out of space actually. Hold on 1 minute. I'm going to bring this down. CaCl2. Sorry, these markers dry up really quickly. CaCl2. Aqueous is reacting with sodium carbonate, which is Na2CO3 aqueous, to form calcium carbonate, which becomes a solid, and sodium chloride, which is in solution. Okay, looking at this, what I noticed first is that there's 2 chlorines here on the left and only 1 on the right. So I'm going to put a 2 in front of the NaCl. Then when you see that, I now have 2 sodiums on the right, 2 sodiums on the left, 1 calcium on the left, 1 calcium on the right, 1 carbonate is here on the left, 1 carbonate is on the right. This reaction is now balanced, okay? So what this reaction is saying, that 1 mole of calcium chloride is reacting with 1 mole of sodium carbonate to form 1 mole of calcium carbonate and 2 moles of sodium chloride, okay? But our question is saying that we have 0.022 grams of calcium carbonate being produced. Okay. So if we are producing 0.022 grams of calcium carbonate, this is our question mark. We want to know how many grams of calcium chloride did we need to start with. Okay. It's the exact same procedure. We start with the grams, 0.022 grams of calcium carbonate. convert grams to moles of calcium carbonate. Then from moles of calcium carbonate, we use the relationship. In this case, it's just a 1-to-1, but we still need to show that we're changing our substance from calcium carbonate back to the starting material. How much calcium chloride did we need? Okay, so we're changing the units of moles of calcium carbonate to moles of calcium chloride. Then from calcium chloride, we can find the grams of calcium chloride. Okay, that's our plan. And now we're going to begin our conversion. You are given the calcium carbonate molar mass and the calcium chloride molar mass. So that helps matters. Starting with 0.022 grams of calcium carbonate, we convert to moles using the given molar mass, 100.1 per 1 mole. Cancel out the units of grams. We now have moles of calcium carbonate. From moles of calcium carbonate, we need to find out how many moles of calcium chloride reacted to form the calcium carbonate. So what we saw here, 1 mole of calcium chloride reacts to form 1 mole of calcium carbonate. So this is a 1-to-1 mole ratio, but you must still write it out because you are changing from one substance amount to a new compound. Now we're working with calcium chloride. We want to know how much calcium chloride reacted. Now from moles, we can find grams, okay? Grams of calcium chloride will be determined using the molar mass. The molar mass is given 111.0 grams per mole. 111.0 grams of calcium chloride goes on top per 1 mole of calcium chloride on the bottom. Cancel the units diagonally. And then we solve. 0.022 divided by 100.1 times it by 111. What I am getting in my calculation is 0.024 grams of calcium chloride. That's the amount of calcium chloride that would be reacted to form the calcium carbonate.